Hello friends, this is Durga again from IT University, a one-stop shop to learn all the technologies. So at this time we are talking about Sqoop. We are in the middle of the workshop, and this is primarily for the backup for my live audience, but anyone can actually go through my content and practice. And if you need environment to practice, you can use labs.itversity.com. These are the plans: 14.95 for 31 days, 34.95 for 93, and 54.95 for 185 days. Further, whether you signed up for lab or not, if you have any questions, you can actually go to discuss.itversity.com and start writing the questions. And there are an army of volunteers who are actually helping answering these questions. And we will be supporting you if you run into any issues. Now, that being said, let me start the WebEx session and then we will continue on the workshop. We are currently talking about Sqoop. So I'm back. Sorry for the extended break. Now you should be able to see my screen. And also I'm starting recording. People on WebEx, please confirm that you can see my screen and also you can listen to me clearly so that I can proceed further. Hello guys, can you guys see me? See my screen, and can you guys hear me? Okay, thank you. So now let us start. So we have seen Sqoop import and export, import all tables, eval, almost everything related to Sqoop. Actually, Ramesh have sent an email. He might not be joining today's session, but he asked me to explain how to merge the data. Okay, so far we are just copying the data from source, especially when it comes to Sqoop import. We are getting data from the source databases and copying to HDFS. We are not actually merging anywhere. So merge is not as trivial as we do in relational database. Relational database have update, insert, and merge statements using which you can easily merge the data. Whereas in HDFS, we primarily deal with files, and we don't actually operate on individual records. For that reason, we cannot actually update the individual records. So merge process is not as trivial as running a update command when it comes to Sqoop importing data or copying data from relational databases into HDFS using Sqoop. So there are a series of steps which we need to follow. Okay. So for that, let me go to my GitHub account. I have a sample. Let me see. Instead of GitHub account, I'm going to itversity.com. So this is important for the projects, but for certifications, you don't need to worry much about it. Okay, but for projects, you should know how much happens, and if it has to be ongoing process, you have to ensure that you develop it properly. Okay, I think I did not create. Just give me a moment. I should have it. Let me see. Import. Yeah, it's over here. So merge process is a multi-step process. First, you have to do. There has to be multiple locations. One is the target directory. So this is the target directory into which data is copied for departments. I just fetched the department's data from the source and I loaded into departments. So our target location is, let's say, this one. And then there are some changes on the source database which I want to merge. One is update and second one is insert. Okay. And using where condition, I have done incremental load by passing department ID greater than or equal to 9,000. If you have timestamp column, you can use timestamp column. One of the best practices as part of the data modeling in relational databases is to have a create date and update date, create user and update user. They are not business columns, but they give they have a lot of significance whenever you want to troubleshoot certain issues. Okay, they are called as audit columns. So most of the tables in relational databases, they will have this create date, update date, create user, update user as part of the tables. So if you have something like update date, you can use that and you can get the incremental load. Okay, and in this case, it will get fetch two records. One is 9,000, which is already existing, we have updated here, and the other one is 10,000, which is just inserted. Okay, now that the delta is actually copied to departments underscore delta. Our actual data, which is the destination directory for all subsequent processing purposes, is this one, Sqoop merge departments, and this is just a stage location before merging, which is departments delta. Okay, now Sqoop provides a command called merge command. We can go to the syntax by saying Sqoop user guide. And also let me paste the link over here so that you have idea about where this material is. Okay. So if you go to Sqoop user guide, 1.4.6 is the version which we are interested in. And if you go to Sqoop merge, so these are the arguments which you need to understand. What is the merge key? Where is the new data? Where is the older data? And what is the target directory you want to copy the data into? Okay. So in our case, if you go here, I am creating a, okay, yeah. So this is the old data set which we are trying to merge, and this is the new data set. So this will have whatever data copied as part of the first import, and this will have two records. Okay. So it will fetch data from these two locations and it will run a MapReduce job internally, and the output will be copied to this target location. Okay, what it will do is it will do a full outer join internally, and then using the full outer join logic, it will identify which record has to be used from new data and which record has to be used from existing data, and then it will actually copy into the target directory. Okay, and the target directory, which is departments underscore stage, will have the merged data. Now our actual directory is this one. This has to be the final one which should have the data, because some subsequent application might be processing from this location. Okay, so what you can do, you can delete the existing directory and now move files from departments underscore stage where we have the merged data into the target location, and then our merge process will be completed. There is another way also to do this. Instead of doing this, what you can do is you can actually say, you can copy from this location into a stage location first, and then get the new data, and then clean up the target location, and then merge it directly onto that location. So it depends upon your decision when you want to remove and copy the data from stage. Either you have to remove this departments directory earlier and copy data that is merged to this location, or you can do it in the later step. So it's up to you how you want to design. You can think about it, and you can come to the conclusion. But bottom line is you need to have three locations. One is where your old data, second one is where your new data, third one is to which location data has to be merged. And once the merge is done, in this case, I'm copying to the original location. Instead of using hyphen rm, hyphen r, I can also delete and then copy. I can also say hyphen cp, copy, and I think hyphen f to forcefully copy to that location, which will replace the files without any downtime. It will be copied. If I remove the directory, if someone try to read at that time, it might get some outage, but it doesn't matter. It will not be a big outage. So it's up to you how you want to do the merge. So this is how you actually do the merge, because we don't deal with individual records. We have to deal at the file level. Okay. Any questions here? It is very, very important from the project's perspective. For the certification perspective, you don't need to worry much about it. If it is not clear, I will reiterate this again so that you understand. Very, very important when it comes to projects. If if your project requirement is this, it actually complicates your project quite a bit, and based on that, you should commit to the client or management. Otherwise, you will be in trouble. Don't assume that, don't take it easy by thinking from the relational database perspective. Okay, so this is also one of the real-time challenge about merging data from the source, merging delta into the existing data set is one of the real-time challenge, and we have to use Sqoop merge, or we have to come up with our custom application. Using Hive also we can come up with our custom application. We will see at the time of Hive once again. And then I will ask you a question. Let's say there is a source database and I want to pull the data. Okay. Is the Sqoop advisable in all the scenarios? If not, can you give me the scenario where Sqoop is not advisable? Okay, it is very, very important understanding this question, and this question should come to your mind whenever you want to connect to source database and get the data using Sqoop. The question is Sqoop advisable in all the scenarios where we have to get data from relational database? If not, our relational database or data warehouse, whatever it is, traditional databases. If not, what is that scenario when Sqoop need not be a good idea? I will give 30 seconds, think about it, and give whatever answers come to your mind. Just uh, guess it wildly. Wild guesses are also welcome. So this answer is not completely relevant about the question I have asked. Okay, even in talent internal uses Sqoop. Sometimes when you try to get data, it partially answers the question. But my question is Sqoop advisable in all the scenarios? If not, when it is not advisable? And it applies to any ETL tool, even with using traditional ETL tools also. It is not, it need not be the case that you can pull the data all the time by connecting to the source database. Okay, so I will answer that question. No, it is not advisable to consider Sqoop in all the scenarios. First, you need to understand the side effects of Sqoop. Okay, so I will give few scenarios, and I'm trying to just build the logic in your mind so that the right questions come to your mind when you actually on the project. I will not be able to cover all the scenarios. I will try to cover few important scenarios. Okay. First thing you need to consider is whether you want to use pull strategy or push strategy to get the data from source database. It's not only relevant for with respect to big data, even for with traditional databases or data warehousing applications, or even with traditional ETL. First thing you need to think is whether we should go with pull strategy or push strategy. Okay, what is pull strategy? So there are multiple stakeholders in the project. Okay, let's take the example of a retail database. Take the example of Flipkart. Flipkart e-commerce platform, let's say, is running against Oracle. All the transactions are loaded into Oracle. Okay, and there will be a owner for that platform, right? That retail platform, there will be a owner, application owner from IT perspective. Okay, whose decision will be ultimate. You cannot override his decision, and he is responsible in keeping his database and application up and running all the time, meeting the SLAs. If something goes wrong, the impact should be as minimal as possible. Now, Flipkart is heavy volume e-commerce platform like Amazon or any other, or Walmart, which is a retail, heavy volume retail platform. Okay, in those scenarios where your databases are highly sensitive, okay, typically those guys will not let you to pull the data. What will happen if they let you to pull the data by using Sqoop? Let's say you want to copy a data which does not have which is from a very big table and which does not have indexes, and you tried with single thread, it is taking forever, or it might be running into some errors such as snapshot to old error, which is typical in Oracle when you try to run a select query which take very long time. As it is taking very long time, you are tempted to use number of threads more than one. Let's say you use number of threads as 4 or 8 or 16, whatever number that came to your mind. What will happen? 16 threads will result in 16 connections to the database, and each thread will do a full table scan because you don't have indexes on the source. You use split by clause with number of threads as 16 because you want it to be faster. So people who don't have much insights into the database, they play with whatever they have in their hand. And number of mappers, you read somewhere that it can increase the performance, and you just add it to 16. So there will be 16 connections to the source database, and each connection will be doing a full table scan to get the data. What will happen? Your source database will go for a toss, and it can impact the source application. So in 99% of these high volume mission critical applications, the source application owners will not let any downstream guys to pull the data. Whether Sqoop is a solution or not, it's a different story. First of all, they might not even let you to connect remotely. Okay. So you have to think from that perspective, whether pull strategy can be applied, whether the source application is mission critical. Sometimes even if they let, if it is mission critical, you need to understand the side effects of playing with this number of mappers, and you have to review the code and also the Sqoop commands that are being generated by the code, and make sure that it does not use the resources abnormally. Okay. So that is one aspect. Whether to use pull strategy or push strategy, you need to have a questionnaire and confirm whether you want to do pull or push. Okay. Let's say pull is not possible. So what is the solution? Can anyone guess? You cannot use tail end also. Tail end also you has to connect to the database and pull the data. And source applications will not let you to do so. So if pull is not a strategy, we cannot use Sqoop at all. So the way it will work is you have to brainstorm with the source application team, okay, and come up with a technical DB transaction logs. Very good, Hemant. Very, very good. It's pretty impressive. That is one solution which we can think. But integrating with Hadoop is not that trivial with DB transaction logs. But yeah, that is one of the it's a very, very good solution. If you have tools like Golden Gate or Shareplex, if you are trying to get data from source database. Okay, but there are certain limitations with DB transaction logs. We will cover a little bit later. Let's talk about batch loads. We cannot use tail and we cannot use any tool to connect to the source database because pull is not allowed. We will not be able to even connect to the database. They will restrict in mission critical heavy traffic applications. So what you have to do, you cannot take the ownership of pulling the data and loading data into HDFS. You have to work with the source application team. You have to initiate, you have to tell them that you give us the data. And here is the technical spec. Your directory names should be, when you try to give the data, typically they give the data in file formats, either comma separated or tab separated or some special character delimited. In one of my projects, I have used null character as the delimiter. Okay. So we tell them that, okay, please give us CSV files with null character as delimiter. And this you have to also tell them the file naming convention, directory naming convention. Here you need to think through ETL best practices. If you are familiar about ETL, you should understand these things easily. Otherwise, you have to sit and analyze to come up with a solution. Okay, then you will discuss with the source team. Typically, source teams will already have existing applications. You just have to either accept their standard or you have to set the standard for them, and it's their responsibility to give the data, whether it is delta every day, whether it is every week, whatever it is, whatever time frame it is. The onus will be on them to extract the data from the database and give it in the file format to you. So how they are getting and all, you don't need to worry about it. It's not your job. Here there are two different stakeholders. One is application owner, and the other one is probably you who is working in a data warehouse project or a analytics project. So you both have to come up with a common technical specification where they give you the data, and then you have to build an application to load it data into HDFS or traditional data warehouse, whatever it is. Okay, so that is how, if pull strategy is not allowed, that is called as push strategy. It's the application owners who will be pushing data for you, and then you have to load into HDFS, and that's where the gateway node have significance. So there will be a file server to which data will be copied, and that file server have to be mounted on the gateway node, and gateway node has to have an application. It could be Scala based or Python based or shell script based or Java based application, which will read the files from that file server and load into HDFS. It's a two-step process. Sqoop is a one-step process. Here it is a two-step process. Is it clear about how the push strategy will work in developing the application to integrate data into any downstream system, not just big data? Okay. I hope it is clear for you. If you have any questions, you can ask anytime. I will answer. Now, let's say source database is not very important. I worked for a company called AT&T, which is a mobile company. For each and every production database, there will be a read-only database which will be refreshed every 24 hours. Okay, there will be downtime for this read-only database for a few minutes every night. And the read-only database can be used for all downstream purposes. Okay, and in that case, you can even if you exhaust resources, it will not impact their main application. Hence, you can consider pull strategy to pull the data from there. Okay, so and also from data warehouses and all those things, you need to consider. You can consider pull strategy. So now, when it comes to pull strategy, there can be some tables. So if you think about an application, there will be hundreds of tables, but only 3 4 tables will be very big. Others are typically small. Okay, many of them will be of medium size. Most of them are will be small tables. Small tables and medium tables will not give a lot of trouble on day-to-day basis, but very large tables, especially auditing tables and all those things, are very large, and we have to run analytics on top of it. Even within a day, there might be 10 GB worth of data in those tables. And for performance reasons, on the source databases, the tables will not be indexed. Okay, so even if the pull strategy is allowed, when it comes to dealing with such scenario, sometimes we can use Sqoop to get the data. Sometimes we might not be able to get the use Sqoop. If Sqoop cannot be used, you have to come up with an alternative mechanism, uh, probably reading transaction logs at regular intervals, and then queue up the logs up to a considerable size and load into HDFS, something like that. So even with respect to pull strategy, there could be some tables where connecting to the source database and getting data, getting delta on regular basis might not be feasible. Okay, so you need to do that analysis. Even if pull strategy is allowed, what are the larger tables you need to pull, and you have to ensure that those are covered as part of the POC to understand the challenges and come up with the appropriate solution. Okay, so that's about pull strategy. Also means if some challenges are related to pull strategy, you need to explore few options, and then if it is not possible, then try to come up with custom application. So most of your mission critical applications or most of the databases will be Oracle databases. Okay. Sometimes what will happen, especially these auditing tables and all those things, very large tables will be partitioned. Okay, as the tables are partitioned, and yeah, they will try to limit the size of the table, size of the partition up to considerable, within considerable limit. They will not let it grow abnormally. So if the tables are partitioned, you need to consider something called DIY, DYP, which is do yourself parallelism. Okay, so if there is a very big table, let's say 100 GB, and every day 10 GB of 1 GB of data is added to the table. Okay, and fetching that 1 GB of data, 2 GB, whatever delta over a period of time, fetching that data is taking too much of time because there are no indexes on the source table. Even though the delta is only 1 GB, to identify that 1 GB, you have to pass or you have to read 101 GB worth of data, okay, to identify the delta. So that read will take abnormal amount of time. Okay, sometimes these tables will be partitioned. For example, let's say the table is partitioned on some key, and each partition will not grow beyond 2 GB. Okay, so if you just use number of mappers as 4, as we don't have indexed column, it will try to establish 4 different connections, and each connection will apply where condition, which will not use index, and it will take its own time to get the data. But if the table is partitioned, what you can do, you actually write a Sqoop command, which will read one partition at a time. Okay, and you should build the logic to create multiple Sqoop imports going to different partitions at a given point in time. It could be 4, it could be 6, it could be 8, it could be 16, whatever number is feasible. And instead of doing full table scan using 4 different threads, now we are trying to use different Sqoop import commands touching different partitions. When you talk about partition, you will be reading one partition at a time. You will not be reading the entire table. So we can get a very high degree of parallelism, and your import can be significantly faster. So you have to keep those options also in mind. Sometimes num mappers might not be the solution, especially while copying data from partition tables. You might have to consider about uh, about do yourself parallelism DYP to read from multiple partitions in parallel at the time of Sqoop import, and that logic has to be implemented as part of your application. Sqoop does not provide that feature out of the box. Sqoop just will provide you the command. You can use query, and you can actually read data using partition clause to read from partition table, and you have to generate that query at runtime so that each connection will go to a different partition. So instead of 4 connections reading 101 GB worth of data to get that 1 GB worth of data, now let's say you are using 50, there are 50 partitions. So there will be 50 jobs. You can control how many jobs you want to run at any point in time. And each of these 50 jobs will only touch 2 GB worth of data. And hence, you will get a very high degree of parallelism. Okay? So you need to keep those things also in mind when you try to come up, when you are trying to come up with application which needs to pull data from a very large table at regular intervals. And these are not only relevant to big data. Any ETL projects, whether it is into traditional data warehouse or big data applications or any other thing, you need to keep these things in mind. I have covered multiple scenarios with respect to getting data into HDFS. What I have covered pull versus push strategy, and then within pull also, sometimes you might have to discard Sqoop while importing a very large table at regular intervals. And third one, if a very large table is partitioned, you might have to consider do yourself parallelism so that you get high degree of parallelism to get data into HDFS. Okay. Any question here? Now I will talk about Sqoop export. You have to keep some things in mind while even doing the Sqoop export. Okay, so let's talk about Sqoop export. So Sqoop export also, when we try to export the data, it will establish multiple connections to the target database into which data needs to be copied. Okay, so when it comes to relational databases such as Oracle, okay, it actually does IO at the block level. So you need to get the details about what will be the impact on the target database, and you have to get the AWR report and see if the export is happening in parallel or not. If there are any log events happening on the database because of that, you have to talk with the database experts to see if the export is going on as expected, if the data is being loaded in parallel as expected without any logs, which will end up making it sequential. Okay, you cannot just expect that run Sqoop export with n number of threads, and all the threads will load the data in parallel. You cannot conclude just by looking at Sqoop logs. You have to talk with the target database team. You have to sit with database experts and see if the true parallelism is happening or not. Again, this is not limited to big data projects alone. It is limited to, it can be considered with any data integration project where data has to be exported to a relational database. Okay, I will give you an example here. I was working with a leading bank, and they are running a data load, okay, using Informatica. Not Informatica, Ab Initio. They were using Ab Initio, and they're trying to load data into a database table, and the commit rate is very high. So they're trying to commit every 100,000 records. I think they're committing at the end. They're not issuing intermediate commits. So they are using 4 threads to import data into relational database. And there is, with respect to Oracle, there is something called init-trans. Okay, don't worry too much, don't try to get into that, but keep these things in mind so that you can actually troubleshoot the issues more accurately. So because of this init-trans, even though they are running in parallel, it's becoming sequential. At the testing time, they will not have enough data. So testing wise, they didn't feel much difference, but they felt that when they push it to production, it will use all the 4 threads and it will load data in parallel. And if with one thread, if it takes 1 hour, with 4 threads, it might take 15 minutes. That's what their assumption, and they pushed it to production. And in production also, they are not getting huge volumes on daily basis. Okay, only once in a while, they are getting huge volumes of data. Okay, because they are not getting huge volumes of data, whenever they are not getting huge volumes of data, the issue is not obvious. There is an issue, but it is not obvious. So whenever they hit a huge volume of data, then the SLAs are going for toss. The import is taking forever, and data has to be loaded within a given point in time. So instead of using 4, sometimes they try to use 8, they're trying to use 16, thinking that it will improve the performance, but it is not. Then I actually troubleshooted the issue. It is with respect to init-trans. So how the Oracle will work is, if a block is touched within a transaction. Okay, so let me do a whiteboard here so that it is clear for you. At least up to some extent, you will not be able to digest everything. I am sure about it, but at least some extent you will try to understand. Okay, here I am creating a new file. So when it comes to Oracle, if you have a table, data will be stored in database file. Let's say there can be a number of files. Let's say this is file 1, and then this is file 2. And table name is, let's say, subscribers, which have 10 gigabytes of data. Okay. Within the physically data will be stored in database files. Okay. And these database files will have something called extent. Extent is nothing but a contiguous blocks. Okay, if the extent size is 1 GB, there will be 10 extents like this. And each extent is 1 GB. And again, extent will be nothing but a block. Okay, so when you actually do any transaction in Oracle, because Oracle is the database which you will be using in production. Okay, for each table and each index, the data will be stored physically in blocks. In block, there is a slot for transactions. Okay, so let's say you are trying to use 10 different connections and trying to update data in these extents. Okay, and you are only counting at the end. So let's say the condition of update is, one condition is where some region equal to west, and other condition is east, something like that. So there are 10 different conditions using which data is being updated. So data related to west might be in all the blocks, data related to east might be in all the blocks. Similarly, for each condition, data will be in all the blocks. Okay. Now, let's say the first thread actually issued the query, and whatever block it touches as part of the transaction, it will use this block header, which will have the transaction information, and it will lock that. By default, there will be only one entry. So whichever transaction gets hold of it, until the transaction is committed, no one can touch that. So what will happen for this any for this transaction, for this header in the block, which will hold the transaction related information, all the other threads will be in queue. So even though you are using 10 parallel threads to load the data, if the init trans is only one thread can actually update all the blocks. Until it is committed, no other transaction will be able to update the records in those blocks, whichever is held by the first transaction which is in action. So due to that, the data load process becomes sequential. Now, if I change this init trans to 10, and we have to do it for both table as well as index, because even at index level, it will by the default init trans is 1 for table and 2 for index, which are good for transaction based applications, but not good for batch loads. So to fine tune the batch loads, you have to consider increasing the init trans. Now each block will have 10 slots to log. So 10 transactions can say that I am doing I'm updating some records in this block, and whenever they commit, they will release those slots, and next one will take. So this is how we can actually get the true parallelism. So you need to understand these internals of the underlying database and see where it is actually achieving the desired parallelism by looking into the AWR reports if it is Oracle database, and also sit with database experts and see if there are any logs when these loads are happening, and then you can come up with the solution. So communication with the teams are very, very important for the successful execution of project. If you just sit isolated and think that everything will run smoothly, and if the counterparty also do the same thing, in the end, it will result in the blame game rather than successful execution of the project. So here, I have emphasized on communication with the source teams when dealing with mission critical application, in coming up with whether to use pull strategy, push strategy, and the technical specification, and also target database teams if to confirm our Sqoop exports are running as expected. So I'm just giving you some idea about the thought process you need to consider to make sure your application will run as smooth as possible. And these things has to be highlighted at the time of requirements gathering or design. And if you did not get inputs, you have to log those things as a risk for the successful execution of the project. And if you already know the risk associated with those things, then you will be able to troubleshoot the issues more accurately. Okay. So as I have mentioned to you yesterday, today's class is purely theoretical. And with this, we wrap up the Sqoop import and export. From Monday, we will start with Hive, fresh. And also I will give you an exercise with respect to Sqoop, one more exercise. Let me think about it and I will come back with the exercise. But from Monday, we will start with Hive. Monday or Tuesday, we will start with Hive. If you want me to spend some more time on Sqoop on Monday, I will be glad to do so. Otherwise, we will start with Hive on Monday itself. If not, we will start on Hive on Tuesday. Okay? Thank you, Sunil. It's not about drinking some water. my throat has gone for toss. I screamed a little bit a few days back, and that's when it gone. Thank you very much for your concern. So any question here? Again, I will give 15 seconds. And if you don't have any questions, we'll wrap up for today. Okay, so today's session is very, very important. You can get skills, syntax and semantics very, very easily by going through the user guide and just practicing it over a period of time, you will get it. But whatever I have explained today is very, very important. So Amit is asking, do you have any mechanism or command in Sqoop which would handle the scenario to transfer the data based on partition for each thread? Uh, uh, no, there is no out of the box, but you can use query. So for example, if I sorry, not root. Here I am connecting as retail underscore DB, DBA. And also as far as I remember, there is nothing like that. But go through the Sqoop user guide and see if there is anything related to partition in that at the time of import, and let me know if I missed that. Okay. Here -p, and I am entering the password. Now I am going to retail underscore import. Okay. Show tables. So there are a bunch of tables. Let's take this orders table. Okay, if the table is partitioned, the query in most of the databases, the syntax work. We can say partition and then give the partition name. If there's a name to the partition, and it will only query from that partition. And also, when you use where condition, where clause, and if the column in the where condition, let's say the data is partitioned by order date, if the filtering is happening on the partitioning column, then automatically it will touch only that partition. Okay, so even with a table using where condition, if you have this condition, it will automatically touch the partition and fetch the data for you. Okay, or you can also use query, and in the query you can say select star from orders where and give the partition condition, or you can also give the partition and partition name. That's how you can actually read data from a partition and then import into the HDFS. This is called as partition pruning. Whenever you specify partition column, especially with list partitioning or range partitioning or even hash partitioning, automatically it will only touch the partition in which the corresponding data is there. If you don't use the partition column as part of the where condition, then it will not touch the partition. It will touch the entire table or index. Okay, I hope it answered my question, Amit. If you have any follow-up question, please respond to everyone. So Sumit is one question, please. How can we move high volume of data which is not on gateway node to HDFS? So where do you have this data? If not on gateway node, where do you have this high volume of data? Based on that source, we need to analyze and we have to come up with the solution. Sumit, any network PC? Okay. So when it comes to HDFS, we have seen how to copy data from local file system into HDFS, right? So there is something called HTTPFS, okay, and also NFS. So if you have a network PC, you have to mount it onto the gateway node, or you can also use NFS server if it is configured as part of your HDFS or HTTPFS, which means that you need to have a HTTP web service serving your files, and then you can use HTTPFS URL to copy from that HTTPFS location into HDFS. I think using copy from local or CP command, you can do that. I never tried that, but you can give a try. So you can actually copy, but for that you need to have HTTPFS configured on your cluster or NFS. There are multiple services within HDFS itself. So let me go to Ambari here. And here you see NFS gateways are not configured. If you want, you can actually say service action, or you can actually go to NFS gateways here, actions, all hosts. Let me see. HDFS, it is a service thing, so we should see this here. If it tells us using Gambari, enable move. Okay, they did not provide adding NFS gateways here. Let me see, add service. No, I think you need to add it while setting up HDFS itself, or you have to use REST APIs. If it is set up, if the NFS gateways are set up, you will see here. And also there is HTTPFS also. You can set up that also onto the existing Hadoop cluster. Okay, then you can actually copy directly and data directly from other file systems, remote file systems into HDFS. And another classic example is S3. You can even connect to S3 and get the data to HDFS. I think copy command or copy from local command will work. For that, you need to give S3 credentials at the time of running that command. Okay. Any other question here? Yep. Sure, Sumit. Okay, I will give 15 seconds. If you don't have any questions, we'll wrap up for today. Okay, there is one question from Amit. That's correct, Amit. So if you want to go with do yourself parallelism or DYP in short, you need your application should not only be able to generate these 10 different Sqoop commands, it also should submit Sqoop commands in parallel, and the number of threads that can run in parallel should be configurable. Okay, that will be the most reliable application. In one run, you might want to use 4 threads. In one other run, you might want to use 10 threads. It's up to you. Okay, it should be configurable. So you need to embed that entire logic using shell scripting or Python or some other programming language or scripting language. Okay, I will take one more question if you have any. Otherwise, we will wrap up for today. 10 seconds. If you have any long question, just type it, saying that there is some question coming in queue. Okay, then. Thank you very much, and we'll catch up on Monday. Have a nice weekend. Bye. Okay, those who are on Google Hangout or YouTube Live, thank you very much for joining today's session. We will resume on Monday, and we will take it from there. And if you need environment to practice, again, please sign up for labs.itversity.com. These are the plans. And if you have any questions, please use discuss.itversity.com so that your questions are answered in timely manner. And we'll catch up on Monday again. Have a nice weekend. Bye.